Okay, so here's our 8.4 notes video. I am skipping these problems up top just to save on time. I'm going to get into the new content. So this is 8.4 chords and arcs. Try to make the video quick, so if you're gone, you don't have to watch a long video. So two chords are congruent if and only if their arcs are congruent to each other. So their arcs are congruent to each other. Oh, running out of room. So if AB is congruent to CD, then we know that their arcs are also congruent. So AB arc is congruent to CD, their arc. Okay, so we have to have, these are our two chords. Remember, a chord goes from one point on the circle to another point on the circle. So here's two chords, so we know that if these are congruent as well. Okay, and it goes vice versa. So if you know the chords are, if you know the arcs are congruent, then you know the chords are congruent. We also know that the chords have to be equidistant from each other. So they are congruent if they are equidistant from the center. So we have to know that if AB is congruent to CD, then FE is congruent to GE. Okay, a diameter, so if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So remember, perpendicular is this little symbol right here. It's when two segments intersect at a 90-degree angle. Okay. So if that happens, then we know that EF is congruent to EG. Then we know that AF is congruent to BF, and AB is congruent to CD. And then lastly, we can say that AH arc is congruent to BH arc, and AB arc is congruent to CD arc, and CI arc is congruent to DI arc. So essentially, all of this just means that on our picture that we have congruent arcs. So all of these are all congruent. The whole arc is congruent to the whole thing on both sides. We know that each of these segments are congruent. Let's use 3 lines since I used 2 for the whole thing. And these little guys in here, I'm going to use a line with a circle. They're also congruent. Okay, so all those little pieces are congruent on our circle. So I'm going to zoom in. So pause if you're not done writing all this stuff in. So directions, we want to find the indicated value. So we need to find x. So we know that here are two chords and they're congruent to each other, which means their arcs are congruent. So 7x plus 24 is equal to 115 degrees. Okay, so these two little degrees are equal. So we don't really need the parentheses and the degree symbols. Just solve it like normal. So minus 24 from each side, so we get 7x is equal to 91. Divide by 7. 91 divided by 7, x gives us an x of 13. Okay, so chords were equal, so arcs were equal. Number 2, So we know that the arcs are equal this time, which means we know that our chords are equal. So let's set them equal to each other. So 18x minus 2 is equal to 52. Add 2 to both sides. So 18x is equal to 54. Divide by 18. And x is equal to 3. Okay. Again, if this is going too fast, just pause the video anywhere. I'm just trying to make a quick video. Number 3, so we don't find x. Well, here we know that our two chords are equal, which means our two arcs are equal. We know one arc value, but we need to find the other arc value. This is not a diameter. It doesn't go through the radius. So we need to find our arcs. Well, we know that 360 minus 76 is going to give us 284. 284 is both of these together. Well, if they're both the same, we can just divide that by 2 and get us 142. So each of these is 142. So now take your arcs, put them equal to each other. So 6x minus 20 is equal to 142. Now you solve like normal, so add 20 to both sides. So we get 6x is equal to 162. Divide by 6. X is equal to 27. Okay. So in this problem, number 5, in the circle Z, RS is 18. So we know that this is 18, the whole thing. And our arc measure of TY is 42 degrees. So there's a couple things going on here. We know that this segment and this segment are congruent, which means these chords have to be congruent. So it's intersecting at a perpendicular. So it's everything that we need from up top in our definitions. So we know that RS and TU are congruent, so they're both 18. We also know that all these little pieces are from our arcs are congruent. And we know that this is being bisected in half. So all of these little, let's use two lines because there's already a line. It's already marked right here, so let's use 2 lines there. Now for our W and SW, let's use 3. Okay, so if we know the whole thing's 18, that means all of these little pieces are 9. So we know that we're looking for TV. TV is 9. TU, 18. WS, 9. Our arc, YU, well, it's congruent to TY, so these are all 42. So it is 42 degrees. Now we want the arc for RS. RS, 42 plus 42 gives us 84. So RS is 84 degrees. Okay. Oh, looks like I skipped number 4. Okay, let's go back and finish number 4. So DE is 11x plus 15. So that's for our segment. And FG is 32x minus 27 for this segment. We want to find D. Well, we know that because they are equidistant from the center and they're intersecting at a right angle, they're hitting at a right angle, we know that these are two chords are congruent. So let's put them equal to each other. So we know that FG is equal to DE. So 32x minus 27 is equal to 11x plus 15. So minus 50, wrong way. Add 27 to both sides. And at the same time, just to save steps, I'm going to minus 11x. So that cancels out my 11x, so we get 21x. And now here, those cancel out, and we're given 15 plus 27 gives us 42. Now divide by 21. X is equal to 2. But the question wants us to find DE. So DE is equal to 11x plus 15. So 11 times 2 plus 15 gives us 22 plus 15, 37. Okay, now that is the end of our note bucket. So make sure you get all of these copied in. If you want to try and do these top ones on your own, it's just a review. I know that they're posted in the PDF in Classroom as well. I just didn't want to make a video for something that we've already have a video on.